I am pleased today, this evening, to welcome you to our today's class in mathematics. And I have a question here that I want us to look at as a team so that you can be able to arrive at the answer that the examiner was requiring us to provide during this examination. And the question has been extracted from a topic called circles, chords, and tangents. So the diagram below represents the cross-section of a petroleum tank made from a circle center, or A, B, and C, D are equal chords measuring 2.4 meters and are 1 meters apart from either side of the center of the circle. AXB and DYC are segments cut from the circle to form the cross-section. The tanga is 8.5 meters long. The first question, calculate the radius of the circle. So I first need to draw the diagram so that you can be able to get a clear picture of how that cross-section looks like in terms of the shape of that tank. And we will expect to have this. This is our circle, and we must have been told at one point that a circle is of course circular in terms of any description, and any length or any line that passes through the center of the circle and has to touch two sides of the circumference of that circle must be referred to as a diameter. So a diameter passes through the center of the circle and touches two sides of the circumference of the circle. So I can be able to call this A and this B. These are the two ends of the diameter of this circle given here. And any line from the circumference of the circle to the center of the circle is called a radius. So that's our radius, and this is obviously going to be our diameter. Correct. And we expect this part to be a semicircle and this part to be a semicircle. To me, a diameter can divide a circle into two equal parts. And those parts that form that circle, resulting from what the diameter has done in terms of the division of that circle, are referred to as semicircles. Semi, half a circle, semi, half a circle. And if I literally come up with another circle, for your information, and if this becomes my circle, and I have these lines, look at that. Any line that touches two parts of the circumference of a circle and does not pass through the center of a circle is called a chord. So this is called a chord. A chord is a line that does not pass through the center of a circle, but touches two sides of the circumference of a circle when drawn internally or inside the circle. So that at the end of the day, we can have this as a segment from the word a section. So a segment is formed by a chord and an arc. You see? So this can form what we call the arc length. So the arc length of the circle is part of the circumference of this circle, and the chord can form what we call a segment. And because this segment seems to be smaller, it gets referred to as minor segment. It gets referred to as minor segment. So this remaining part that is larger than these other parts can get referred to as major segment. Major segment. So a chord and an arc of a circle, or this arc length, will form what you call a segment. Due to its size, it becomes the minor segment, and the remaining part can form what you call the major segment. Between this chord and this arc is now the major arc. So this becomes the minor arc because it is smaller, the minor arc, and this is now the chord forming the minor segment, and this chord as well, and this major arc forming what you call the major segment. So between this chord and this major arc, you can form what you call the major segment. This one here. And of course, you should also be able to note that if a circle is drawn as well, and so this is just an introduction to what we've been given as the question here. So if I draw this as my circle, and there's this line, this gets called a tangent. A line that does not pass through the center or does not pass through the circle and touches the circle at its circumference is called a tangent. It is called a tangent. A line that touches or makes contact with the circle at one point on its circumference is called a tangent. And you can also be able to have something called a secant. A secant can literally serve as a chord since it passes through the circle but not at the center and gets extended to actually find its way outside the circle. It's called a secant. So seconds can get to that point of passing through the circle, but not literally at the center of the circle and find their way to the outside of the circle. So they get called seconds. So this is just a brief summary of what circles, chords, and tangents refer to, and you should be able to know how these parts can get well explained in terms of what you're supposed to answer regarding to any question that can get brought under this area. And let's get back to the question. So I think you have actually had a chance of getting this information, and we can now be able to proceed what the question is asking us to get. So let me get rid of this so I can be able to just come here. So I'm actually given this question. So this is my circle that the question has brought. And this circle has two chords. This is the first chord not passing through the center of the circle. And we have letter A here, letter B, and letter X. So this is shaded. And again, we have another chord here, okay, that is not passing through the center of the circle. And this chord is labeled C, D, and then Y. So if you look at this keenly, you'll realize that this is a chord that needs to actually end up giving us what we call a minor segment, and this is also a chord that gives us what we call a minor segment. And I've told you these chords are of equal length, each 2.4 meters, as per the question's information. And we are told these chords are 1 meters apart. They are 1 meter apart. So let me just make it very, very clear. So 2.4 meters, and again here 2.4 meters, so also 2.4 meters, and they are 1 meters apart, so 1 meter apart. So look at that. So this is our diagrammatic representation of this question. So they are saying the tanga is 8.5 meters. I think you must have had a chance of getting those tankers that normally transport oil or petroleum products from one point to another, maybe from the manufacturer's point of manufacturing to the distributor or sellers or petrol station. So this is the cross section of that tank. It has been made by cutting out segments, these shaded parts. They took a circular part or a circular metallic shape of a particular material and cut out segments from this circular section. So the first segment was cut off just at the top, and the other one was cut off just at the bottom. And the distance between the segments that were drawn on this circular part before the segments got cut out was 1 meter. So they measured a chord 2.4 meters, another chord 2.4 meters, between them was 1 meter, and they cut out the segments getting formed on either side of those chords. So this should be the shape of that cross section of that tanga, which is 8.5 meters. So the first question is asking us to get the radius of this circle. So how then do we get the radius of this circle? We are going to actually do this. We shall be able to just make a drawing from this end to this end, and from this end as well to this end. Correct. So, and we can also do this end to this end, and this end to this end. And I know very well the distance from here up to here is r, which is the same as this, the same as this, the same as this, the same as this, and as well the same as this whole distance. So this is now also r. So I know very well, I can say this is 1.2 meters, and again 1.2 meters. Correct. And that means that now I need to actually realize that this is also 1.2 meters, and this is also 1.2 meters. Now, if this distance and this distance are the same, we can get rid of them. Okay? And the remaining is 1 meters. So if I line it down from this point to this point, and another one from this point to this point, and this to this, and this to this, that means this distance and this distance must be the same. And because these chords are 1 meters apart, then that means this distance must be 0.5 meters, and this should also be 0.5 meters. So I can come up with this triangle, okay, which is an isosceles triangle where the base angles are the same and these two opposite lines are equal. Okay, so if this is a triangle for me to draw, look at that. And I have this as my O, the center, be able to get that. And I take this to be my N, so I can be able to say, let me take this to be C, and this to be D, and this to be the center O. And I know very well I can drop a perpendicular line from this center to the base of this triangle, which is now the chord CD. This chord CD, and this chord is 2.4, so it's equally divided into 1.2 meters and 1.2 meters. And I've known that this length is 0.5 meters. So how do I get this part? It is now going to serve as my radius. CO, my radius. I can use what we call the Pythagoras theorem. So I can say, let this be N, this be B, this be 1. C. Now my radius of the circle. So I'll say A squared plus B squared is equals to C squared. My A is 1.2, so 1.2 squared plus my B, 0.5 squared is equals to C squared. So 1.44 plus 0.25 is equals to C squared. Correct. So then I'll actually end up having 1.69 is equals to C squared. I'll introduce square root on both sides, so that my C is going to be 1.3 meters. So at the end of the day, I know very well that the radius of this circle is equal to 1.3 meters. That becomes my answer as far as the radius of that circle is concerned. Correct. And the second part says the area of the cross section. 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 So they want us to get the area of this cross section. What do I do? I'm going first to do this. I'll first get the area of the whole circle, because this was the initial shape of what they used to make this cross section of this triangle. So area of the circle first, area of the circle is equal to pi r squared. So I've been told to use pi as 3.142. So I'll say 3.142, okay? Then I say multiply by z, that's 1.3 squared. Why? The radius of the circle is 1.3. This is what you got at the radius of the circle. It's 1.3 meters. 1.3, 1.3, 1.3. So then I'll come here and say 3.142 times, because that's the area of the cross section. Okay, so we first begin by getting the area of the whole circular part of that material used to make that cross section. So 3.142 multiplied by 1.3 squared pi then r squared. So our answer is 540, so 30998 meters squared. That is the area of the whole circular part. Then we shall come up with a way of getting the area of this segment. So that we just get the area of this segment, we can say times 2. Then we minus from the whole area to get this part. That now serves as our cross section of that triangle. So I'll be able to draw this to make my work. easier. Correct. So I want to get the area of this part. These parts that seem shaded, the segments, at the top and the bottom are the same in terms of size. So you must have the same area. So once I get the area of one, I just say times 2 to get the area of those segments that were excluded from that circle or were cut off from this circle to actually leave us with this cross section. So I know this is 1.3 as the radius of the circle. This is C. This is called the center of the circle. This is D. And this is 1. And I know this is 0.5. This is 1.2. I can get this angle. Then use it to get the area of the whole sector. Then get the area of this part. Then I now end up subtracting from the area of what I got initially as the whole part of the sector. And remember, this part is actually shaded. That was cut off from this circle. So I'll come here and say, I'll use sine to get the angle at this point. So sine theta is equals to opposite our hypotenuse. So sine theta is equals to, my opposite is 1.2. This is my theta, the angle I'm looking for. Opposite is 1.2, hypotenuse is 1.3. So just come and say 1.2 divided by 1.3, and I get the sine inverse of that. I'll get 67.38. So the angle is 67.38 degrees. And because these ends are the same, you can say times 2 to get the whole angle. So times 2, you get 134.76 degrees. That becomes our theta. So let's get into getting the area of the whole sector and then the area of this triangle. Remember this part was actually cut off from this circular part. So get to this other side. So we shall have the area of the whole sector here, say theta over 360 pi r squared minus a half AB sine theta. That means theta over 360 pi r squared, the area of the whole sector. Then a half AB sine theta, the area of the triangular part. We shall be left with the area of this element that was actually cut off. Because this part was cut off, this part was cut off to actually get into this cross section of this triangle. So theta is 134.76 over 360 times 3.14 plus pi given times 1.3 squared minus a half times, of course, AB, we shall take this to be our A and this to be our B, those parts, because a half AB sine theta. So you see the area of the triangle. So a half times A, 1.3 times B, 1.3 times sine 134.76. So answer divided by 360, okay, times 3.142, okay, times 1.69, that's 1.3 squared. So it gives us 1.9877. Okay, then let's get to this other end. So 0.5 or a half times 1.69 times 1.3 times 1.3, then times sine, okay, 134.76. So it is 0.6. So you can get the difference. So minus 1.9877 gives us 1.3877. That's the area of this part only. Then you shall say times 2. So you shall be able to say times 2. So we shall have 2.7754. So that's the area of these parts. So to get the area of this cross section, I'll take the whole area of the circle, which is 5.30988 minus 2.7754. So minus 5.30988. So I'll have 2.534